Hello guys, hopefully everybody's having a good weekend. We're going to go ahead and continue with lesson 3 because we're not going to have the opportunity to do this in class since we're going to have a test next week. So that's why I'm making this video. So please make sure you're taking notes in your books. You should have taken your books home. If not, write it down in a piece of paper. At least watch the video so that you have some idea of what's going to be going on, because whenever I see you the next time, we're not going to go over this. We're going to go ahead and move on, okay? So yeah, we're a little bit behind, so let's go ahead and get started. Lesson 3, Parabolas in Motion, should be in page 675. So we're not going to do this one. It should be, and also we're going to skip this one. So it should be right here. This is the page 675. So let's go ahead and get started. For my A-Day kiddos, I believe we were able to finish most of lesson 5. Lesson 3. But I would recommend just watching this video again, to kind of get a refresher on what we did. If you do know what's going on, just feel free to just fast forward the video until you see where we stopped. But for my B-Day kids, you haven't seen this yet, so this is some new material. All right, let's go ahead and get started. So you are going to have Desmos open. We're going to be learning about transformations from quadratic functions. So a transformation always starts with g of x equals x squared, right? So let's go ahead and graph that one. I'm going to go over here to Desmos. I think I already have it open or not. So I'm going to have to open it real quick. Desmos test mode. And it's usually the second one. Okay, so I'm going to do g of x equals, and then x squared. So this is what it looks like. It's always going to start at the origin. So in your books, I want you guys to go ahead and graph that. Okay, so right here, I'm going to graph it right here. So I think I can draw here. Yeah, I can. So it's going to look something like this. And I suggest you do it in different colors because we're going to be graphing 3 different graphs. So this is the original. Make sure you put your arrows. It looks like a U, right? And then it says, consider the quadratic function shown. Then it has c of x equals x squared plus 3. So how did this function change? They added the constant number of plus 3. So whenever this happens, this is a vertical transformation. Okay, and if it's plus 3, do you think it's going to go up or down? So I'll let you think about that. And let's see. If I do c of x equals g of x plus 3, you can see that the graph went up 3 units. So it was at 0, then it went 1, 2, 3 units up. Okay, so we're going to go ahead and graph that. Over here, let's stick with the red. So 1, 2, 3. It's going to go up about right there. And then now this one, the last one, is x squared minus 3. So this one's going to go the opposite. So instead of going up, it's going to go down 3. So we do this one. What was it? D of x. Okay. Equals x squared minus 3. And you can see that from the original, it went down 1, 2, 3 units. Okay. So you always have to go back to the original to do the transformation. So from the original, from the blue one, we're going to go down 3. 1, 2, 3. About right there. And we're kind of guesstimating on these other points, but you get the idea. So these are the transformations. This is vertical transformation. So whenever it's a positive, or whenever, let's reword that. Actually, we're gonna actually write this down over here. So let me scroll down right here. Right here where it says this right here. So for c of x, it says write the function c of x and d of x in terms of basic function g of x. Then describe the transformation of each function. So we're going to write it down right here. So for c of x, we had g of x plus 3 translated up 3 units. Okay. So the x stayed the same, but the y went up 3, right? So that's why we're going to put y plus 3. And then for d of x, we had g of x minus 3. So this one translated down 3 units. Okay, and this one is going to be the x stays the same, but the y value is what changed here, and it went y minus 3. Whatever that y value was, you subtracted 3 from it. So that's that. We're not gonna do number 3. Let's go down. I want you guys to go ahead and underline or highlight this. This is really important. Recall the function t of x of the form t of x equals f of x plus d is a vertical translation. Okay, so that's what we just did right now. We did a vertical translation. Number 4 says, describe each graph in relation to the basic function g of x equals x squared. Then use the coordinate notation to represent the vertical translation. So right here for A, you have f of x equals g of x plus d when d is greater than 0. So that means that whatever number d is greater than 0. That means that this is a positive number, right? Or positive constant. And whenever they have that, that means that it's going to translate up d units. Whatever d is. So d represents a number. It could be any number. All right. And then for the bottom one, b, it says f of x equals g of x plus d when d is less than 0. So if a number is less than 0, that means that it's going to be a negative number. And this is, or a negative constant. Constant just means a number, right? So this one is going to be translate down d units. Again, we don't know what d is. It could be any number. All right. And then for part C, each point x, y on the graph g of x becomes the point x, comma, y plus or minus d on f of x. Okay? And then for this one, I want you guys to go ahead and practice this on your own. So you feel free to pause this video. You're going to put this one in decimals. G of x equals x squared. We already know that that's the original, right? Because if we go back right here, I'm going to delete this. I had already graphed that. And that's always going to be original. Whenever you see like x squared, just like that with no other numbers, that's going to be always at the origin. So we can go ahead and graph that one. So it should look like this. Now let's go ahead and graph this one. So this one looks a little bit different from the vertical translation that we did. Okay, so let's see what happens whenever we draw that one. So we have k of x equals 1/2 x squared. So the red is the original, and look what happened. So look at the origin. They're both still at the origin. It didn't go up. It didn't go down. It didn't go left. It didn't go right. It got wider. Okay, it got wider. So let's go ahead and make a note of that. So when number is less than 0, graph gets wider. Okay, so it got wider. All right, and then let's go ahead and let's do purple. J of x equals 2x squared. So now this is a number that's greater than 0. So what do you think is going to happen? Let's see. It is j of x, right? J of x equals 2x squared. And look at what happened. So I'm going to take off the purple one so that you can focus on the original and the transformation. So this is the original, and this is the new one. And the number is greater than 0, and it got thinner, right? It got slimmer. So let's make a side note of that. When number greater than 0, graph gets thinner. Okay, and then it looks something like this. Still at the origin, it didn't move left, it didn't move right, it didn't go up or down, it just got smaller, it got thinner. And then the last one that we have here, I'm gonna change the color to I don't know. Let's do purple pastel. P of x equals negative x squared. So whenever you have this, let's see what happens. I'm gonna delete this one. P of x equals negative x squared. And look what happened to the graph. And I'm gonna change the color for this actually, because I want you guys to be able to tell the difference. So the red one is the original, and this is a transformation. So as you can see, it didn't move left, it didn't move right, it didn't go up, it didn't go down, it didn't get wider, and it didn't get thinner. It was reflected. So if I were to put a mirror on the x-axis, it's gonna be reflected across the x-axis. Okay, so that just means that it whatever it was, it's the opposite now. So this is reflection across x-axis. And it looks something like this. It's like the red one, but the opposite way. I kind of drew that one a little bit thinner. Let me redraw that actually, because it looks a little thinner. So it's something like this. That's better. Okay. So a couple of things that I want you guys to know. Whenever the number is less than 0, the graph got wider, right? We're gonna call that phi values are smaller. That's a vertical compression. We call that a vertical compression. So let me go ahead and change the color. This is a vertical compression. And then whenever the number whenever the number was greater than 0, the graph gets thinner. This is called a vertical stretch. So here's some new vocabulary for you to know. You have to know this new vocabulary, okay? And then anytime you see a negative in front of the x squared like this, reflection across the x-axis, that's what it's going to be. This is going to be a vertical reflection. Okay? So those are the main things I want you to take from this. Let's go ahead and move on to number 6. Let's see. All right, it says write the function j of x, k of x, and p of x in terms of the basic function g of x. Then describe the transformation of each function. So j of x equals, what was it? I'm going to have to go up a little bit. J of x equals 2. Where is it? 2 g of x. And this was a vertical stretch by a scale factor of 2, because that was the number that was in front of the x squared, right? If you look back up here, that 2 right there. And then we have k of x. That's going to be, I'm going to go up a little bit. That was 1/2 x squared. So it's going to be 1/2 of g of x. And this was a vertical compression by a scale factor of 1/2. And then p of x, oh, I did that wrong. P of x equals negative g of x. And this was vertically reflected over the x-axis. Okay. So these are some new vocabulary that's really important that you know. All of this is super important for you to know. So please make sure you rewind this video. If it didn't make sense, please email me. And whatever questions you have, I'll be sure to answer them. All right, moving on. All right, it says, recall that the function t of x of the form t of x 8 times f of x is a vertical dilation of the function f of x. So that's what I want you guys to highlight. This is really important. T of x equals ax, 8 times f of x, my bad, is a vertical dilation of the function f of x. Okay? And then let's go ahead and get started with number 7. And this is what I was talking about. So describe each graph in relation to the basic function g of x equals x squared. Then use coordinate notation to represent the vertical dilation. So whenever a is greater than 1, when a is greater than 1, then this is a positive. And actually, let me look at something real quick. I'm sorry, guys. Let's go down here. Okay, got it. All right, let's erase this real quick. A times g of x whenever a is greater than 1, meaning that it's not a fraction. So not a fraction. This is going to be a vertical stretch, okay? This is called a vertical stretch. So the graph gets really thin. It's like really, really thin, okay? And whenever a is less than 0, that means that this is a fraction. Anytime you see a fraction or decimal, and I forgot to put that here, not a fraction or decimal, then this is called a vertical compression. A vertical compression is whenever the graph is like really wide, like this, okay? And then 70. Let me see something real quick. The graph of f of x is a reflection across the. Oh, I'm sorry, guys. Okay, actually, this part I'm gonna have to erase this. Sorry, that's my bad. I had them mixed up. Right here, this is whenever it's a fraction or decimal. So when the number in front of the g of x is any kind of fraction or decimal, this is the vertical compression. And this is whenever it's a wide graph. Okay? When a is less than 0, that means that this is a negative number. And this is going to be a reflection across the x-axis. Okay, so if the graph is like this, that's the original, right? Then the reflection is gonna be going the opposite way, like that. Okay, and it didn't get wider, it didn't get thinner. It's the same graph, is just facing the opposite direction now. All right, and then let's see, part D. So your x value doesn't change, but your y value does. So whatever number you have for a, whatever number you have at the beginning of the function, you're going to multiply that number by your y value. Okay? All right, moving on. We're going to go ahead and skip this part. We're going to skip this one as well. This one too. Okay, right here. All right, it says consider the three exponential functions shown where h of x equals x squared is the basic function. The operations are performed on x, which is the argument of the function. So the argument of the function is the expression inside the parentheses. Okay. So let's scroll down a little bit. Okay. Let's look at the worked example. It says to write v of x in terms of h of x, you just substitute x plus 3 into the argument for h of x as shown. So right here, instead of putting h of x, they're replacing it with the x plus 3. Okay, right here. So what this means that anywhere I see an x, I'm going to put x plus 3. That's what they did here. Instead of putting x right here, they put x plus 3. And then we have another x right here. We have x squared. So instead of putting an x, I'm going to put x plus 3, just like how they did here. Okay. Write the function wx in terms of the basic function h of x. So that means that v of x equals h parentheses x plus 3. And then let's see what happens whenever we put this in the graph. I want you guys to see what happens in decimals. So we're going to graph the original, which was the h of x equals x squared, because we always graph the original first. So that's the original. I'm going to change this to a h, but it really doesn't matter. We still have the same thing. And then I'm going to change it to h parentheses x plus 3. And then look at what happened to the graph. It moved to the left 3 units. Now you might have thought, oh, it's x plus 3, so I think it's going to move 3 units to the right. No, okay? You have to remember that parentheses lies. So anytime you see anything inside of the parentheses, you do the opposite of what it is. So instead of going 3 units to the right, because it was plus 3, oh, whoops, you're going to go 3 units to the left, okay? So whenever it's h of x plus 3, you translate horizontally. Three units left. So what does that mean? Your y doesn't change, but your x does. So this is going to be x minus 3 comma y. Okay. Now what happens if it would have been like for wx, if we would have had hx minus 3. So think about it like this. Minus 3, all the negatives are on the graph is usually on the left side, right? So you would think, oh, I'm going to go 3 units to the left. Nope. Remember, you do the opposite of whatever is inside the parentheses because parentheses lies. So instead of doing left 3, you're going to go translate horizontally 3 units right. Because remember, you do the opposite. So it's going to be x plus 3 comma y. And let's go ahead and check that in decimals. So if I go right here, I'm going to erase that one for now. Hx minus 3. And sure enough, it goes 3 units to the right because parentheses lies and you do the opposite, okay? You just have to remember that. Parentheses lies, so you do the opposite. All right. Sketch and label the graph of each function. Identify the key points. Okay, so we already know the original was in the middle, right? And then this one, it went 1, 2, 3 units to the right, or sorry, to the left. So right here, this was whenever h of x plus 3, right? And then h of x minus 3 is going to go 3 units to the left. 1, 2, 3. 1, 2, 3. So it's going to be like something like this. Okay. All right. So now you should be on page 683. Whoops, where did I go? Right here. So I'm going to go down and we should be on page 683. So this one right here. All right. It says complete each sentence with the coordinate notation, represent the horizontal translation of each function. So v of x equals h of x plus 3. Each point xy on the graph of h of x becomes the point. So this is going to become, remember, the y value doesn't change here, but the x is the opposite of what's inside the parentheses. So since that is a plus 3, in your head, you would think, oh, okay, I'm going to go to the right 3. No, you do the opposite, which is to the left 3. Okay, so we're going to do actually x minus 3. This is inside the parentheses, and you do the opposite. All right, I'm going to change the color. For the next one, w of x equals h of x minus 3. Each point xy on the graph of f of x becomes a point. Remember, the y doesn't change. For a horizontal transformation, the y doesn't change, only the x, right? Because you're moving left to right. That's what horizontal is, right? And left to right is all about the x-axis. So if that helps you remember, think about it like that. So again, inside the parentheses, we have x minus 3. So your mind would tell you, okay, go to the left 3 because all the negatives are on the left side. No, you do the opposite, right? So you're going to do x plus 3. And that's only whenever you have parentheses. Whenever you have something inside the parentheses, you do the opposite. All right, moving on. Moving on to number 7. Describe each graph in relation to the basic function h of x equals x squared. So compare f of x equals h parentheses x minus c to the basic function for c is greater than 0. That means that if c is greater than 0, this is a positive, right? So for this one, if it's it's gonna be h of x plus c, because c is gonna be a positive, then you're gonna move what? Left or right? Think about it while I write this down. So this is gonna be a translate horizontally. Do you think about it? What did we come up with? If it's x plus c, your brain would tell you, oh, go to the right, whatever c unit is. No, you do the opposite, which is horizontally to left c units. All right. When c is less than 0, this is a negative. So this would be h of x minus c. So you're going to translate horizontally to the what? Left or right? If it's A minus c, remember, all the negative numbers on the graph are on the left side, but it's inside of the parentheses, so you do the opposite, which is the right side. So to the right, c units. Okay, whatever c is, it could be any number. All right. We're gonna highlight this. Recall for the basic function the c value of the transform function y equals fx minus c affects the input values of the function. The input values is the x values, okay? So input means, I'm gonna put it on the side. Input means x values. Because remember, whenever you have parentheses, that means that that's gonna be a horizontal translation. And a horizontal line moves from left to right. And the x-axis is it moves from left to right. So if it helps you remember it that way. All right, let's see how much we have left. Okay, we're almost done with lesson 3. Let me go ahead and make sure I don't skip anything. So now go to page 680 right here and copy question 1. So question 1 says write the function mx and nx in terms of the basic function h of x. So this was the basic function h of x equals x squared. Remember, this is our original. Mx equals x squared. Is that what no, I think they meant to put negative x squared. They messed up here. They meant to put negative x squared. This is what they meant to put. Okay, so for this one, it's going to be negative h of x. And for n of x is going to be h. And where is the negative? The negative is inside the parentheses, right? So it's going to be h of negative x. The negative is inside the parentheses. All right, and let me see if there's anything that I want you guys to write down for this one. Yes, there is going to be something actually. Just a second. Okay, yeah. We're gonna go to the next one. So I don't think there's anything else left for this one. Just know that this is gonna be a reflection across the x-axis, and this is gonna be a reflection across the y-axis. Okay. All right, moving on to this one, I believe. Let me double check. Okay, yeah, number 4. So it says use technology to sketch and label each function. Use Desmos to sketch graphs. Okay, so we had our original. As always, this is our original, right? And I'm gonna actually scroll up a little bit to look at these. So that was the h of x equals x squared. And let's do mx equals negative h of x. Mx equals negative h, h of x. As you can see that this reflected across the x-axis, so it went down, right? So let's go ahead and graph that. So I'm gonna erase this right here. This is gonna be our original. We always have to start with the original, right? And then this was a reflection across the x-axis. It didn't get wider, it didn't get thinner, it didn't move left or right or up and down. It just reflected across the x-axis. And then the other one was nx equals h parentheses negative x. So let's do that one. I'm going to take this one off for now. Nx, whoops, equals h parentheses nx. What happened to it? Oh, I forgot the squared. Negative x squared. Oh my god, what is happening? Hold on just a second, guys. Negative. Where did I mess up? Let me look at where I messed up real quick. Okay, I guess they only wanted us to graph these two then. Nx equals negative. Let me try that real quick actually. Equals negative x squared. Yeah, it's not on here. Yeah, so for now, let's not worry about that one. Let's just worry about these two. So this was our original. This was the h of x. And then this was the m of x, okay? And the n of x, we're not going to worry about that one right now because I'm not sure why it's not showing. Yeah, I don't see, not even on the notes that I wrote down earlier. I don't see it. Let me try something real quick. Negative okay, parenthesis negative x. Oh my goodness. Okay. That's that one. Okay, so I see that one. Oh, okay. Let me change the color. Maybe that's not helping. Okay, here it is. Here it is. Here it is. Okay, it's showing that it's the same graph. Which, yeah, so yeah, the reason why it wasn't showing is because it's the same graph. Okay, the original and then the transformation across the y-axis is actually the same for this one. So I'm gonna go up here, and then let's go ahead and move on to number 6. So that's why that one wasn't working. Sorry about that, guys. All right, number 6. Write the x or y value of each of the corresponding reference points on mx and nx. So right here we have negative 2 comma 4, and then the transformation was, whoops, let me need this. Let's go back to this. The transformation was that it was a vertical reflection, or a reflection across the x-axis. So that means that the y value is changing. So it's going to be the opposite, negative 4. This one was negative 1. It's going to be negative 1. 0. Well, 0 stays as just 0, right? And then let me look at the other ones. This one was negative 1 because you're just doing the opposite, and the 2 stays the same, but the y changes to negative 4. And then whenever on the inside is a negative, then your x values are changing, okay? So instead of negative 2, you're going to have positive 2. Instead of negative 1, you're going to have positive 1. 0 was 0 is just 0. Instead of positive 1, you're going to have negative 1. And instead of positive 2, you're going to have negative 2. So these would be your new points that you could plot. And yeah, this is really important for geometry actually, because You're going to be talking a lot about reflections and all that stuff in geometry. So make sure that um, you remember this. So for the m of x, the y values changed. And for n of x, the x values changed. Change sign. Because the number didn't change, only the sign, right? Okay. And then the next one. Here's what's really important about this. Basically, this whole paragraph highlighted. Remember, a reflection of graphs is a mirror image of the graph about a line of reflection. A line of reflection is a line that that the graph is reflected across. A horizontal line of the reflection affects the y coordinates, and a vertical line of reflection affects affects the x coordinates. Okay, so the horizontal line was reflected on the, what's it called, the y coordinates. So this is whenever you have like for example, h of x equals negative x squared, and then you have parentheses right here. So whenever the negative is outside of the parentheses, this is a horizontal line reflection. A vertical line reflection is whenever you have, for example, h of x equals negative x squared, and the what's it called? The negative sign is inside of the parentheses. So horizontal line, this is what it's gonna look like. The negative is gonna be outside the parentheses, and then a vertical line reflection, the negative is going to be inside the parentheses like this one. All right. So we're almost done. Which function represents a reflection of h of x across a horizontal line? So right here is going to be m of x reflects over, what axis was it? M of x was the y-axis. Over the, sorry, no, not the y-axis. I think it was the x-axis. Let me look at it again real quick. Before we write it down, let me look at it. Okay. Over the x-axis. It was the x-axis. Using y equals 0. And then n of x reflects over... remember, this one was the one that was a vertical line. A vertical line is the y-axis using x equals 0. All right, so that's it for this lesson. Please be sure to do the exit ticket. I'm going to be posting that on Schoology. If you have any questions over the lesson, please let me know, and I'll be sure to answer those. Either email me or I could just answer it in class. So yeah, that was it. I'm going to be making the lesson 4 because you all also have to write down notes for lesson 4. We're only going to be doing half, and then the other half, we're going to finish it in class. Okay, so please make sure you write down the notes. That way you're not behind on what we're doing. Thank you guys, and y'all have a great weekend. See y'all next week.